is about answering the questions from our assignment number 1. Like our assignment number 1 is just a exploratory data analysis with pandas, and they gave us a data set called adult data set, and we need to use pandas to understand this data set. So yeah. Did you guys download all the notebook that we sent out, and then we're recording that post? Okay. Yeah. I'm aware that we're recording this session. So this is how the assignment number 1 looks like. They give us 10 questions. And based on the 10 questions, we need to use the Pandas library to write the code to answer those questions. Like first of all, because if sometimes when we write a long line of code, it will looks like we need to scroll to the right to know all the code that we write. It's not a good thing for us to understand what we are writing about. So first of all, I want to introduce a bit about how to wrap the line of code in the notebook so that we could write our code to answer the questions better, like in this assignment. Do you guys have do you guys have the Jupyter notebook open in your computer? We can start a new. Great. So let's create a new notebook. File, new notebook, Python 3. So if you create a new notebook from your end, let's just copy paste like some long line of code. So first of all, you need to just copy paste like import the library from my answer sheet, and then you import the data set. Like the data set should be in the same directory as your notebook. And then, for instance, this line of code is very long. Let's just copy paste it. Tell me if you want me to slow down. Like because my notebook has already been configured to the wrap, like it will automatically wrap the text. However, in your end, it should show something like this. And it's very annoying when you write like such a long line of code. So what we want to do is we want to change this one to this one. And once you change it, it's going to be good for the future. What we need to do is, firstly, we need to get the config directory from the about the Jupyter notebook. So if you open my answer sheet, go to the section how to wrap code text in Jupyter notebooks, copy paste the first line of code, and paste in your notebook and run it. 4, 2, 1. It will list the directory of your config file. my directory is users, my name, and Jupyter. Do you guys follow? Great. And then we need to list the number of files in this directory, in our Jupyter directory. Copy paste here to here and run it. We can see we have a file called nbconfig. And the next thing we want to do is copy paste this config file and make a backup file. So we call the function copy, and then we my highlighted code is the directory, like the notebook JSON is the JSON file of our config file. So you just because this is the directory of our Jupyter notebook, and then you call the config file, which you type in /nbconfig and then /notebook.json. This is how we call the JSON file of this notebook. And then we make a copy of this file and set it as a backup. And then we run it. Shoot. And then we need to type in %load to load this JSON file and see what's inside this JSON file. You copy paste the %load and the path of this file. In my computer, it already shows that markdown cell line wrapping equals true and code cell line wrapping equals true. However, in your end, it should list something cell cm config numbers equals to true, not line wrapping equals true. And we have a question. You can just say it. No such file or directory. Can you type in the path to the conversation chat? Yes, because it's my directory, it's not your directory. Change the name, please. So here, if you type Jupyter config directory, it will show the directory of from your end. Then you use this path. Share Jupyter np config. No such file. What's the results if you run Jupyter config directory? Can you paste in the conversation? Share Jupyter. Yeah, it's the same as what I got. What about the next? If you run list the files in your Jupyter directory. Migrate. Oh, you only have migrated. You do not have nbconfig. Okay. No. Okay. So what you need to do is you need to create a nbconfig file in order to, because you do not, can you instead of nbconfig, can you call maybe notebook JSON directly? Let's say if you have JSON file just in the migrated. Okay, so I will tell you later on how to create nbconfig file from your end. Basically, you just create a new JSON file and then put the information you need inside that file. So for those people who can open your notebook JSON, are you like, do the rest of you guys can open the notebook JSON? Can you guys tell me if you could open notebook JSON? Not really. So what's the error message? I'm using Mac. So Daniel, you call which doesn't where's the error message come from? What's the comment you ask for? So you need to run the config directory first to get the address of your Jupyter notebook. And then you need to find the config file in your folder, which is, you need to make sure that nb config is in your folder. And then you copy paste the folder. You copy paste the JSON file. Oh, I see. Okay. Yeah, for some computers, I think you guys do not have a nb config file, but you can always create the nb config file later on, and then create notebook JSON, and then run this line of code. Terminal or Anaconda. I open Jupyter using Anaconda. What about the rest of you guys? Like besides Daniel and Qianzhen? Do you guys have notebook JSON already in your computer? So I'll just continue then. Yeah. So after you have the notebook JSON file, you're ready to change the code. What we need to do is copy paste this line of code and then call this function write file, because you want to change the file to change the JSON file. So you type in %% write file and then type in the path of this JSON file and then copy paste what I have here. You need to put in line wrapping is true for both markdown cells and code cells. And then type here. So you're overwriting the JSON notebook. And then like after that, if you want to check if your file has been overwritten, then you just load the file again. In my computer, it's this pathway. See, it's the same as what I wrote. Like after we finish those steps, we can, and then you quit your Anaconda and then reopen your Anaconda. Your code will be automatically wrapped, like in the future. So this is a small tip on how to use the Jupyter Notebook more efficiently. Do you guys have any questions? I'll talk with Daniel and then you need to Google it to create an nbconfig file. There's a command line. How to create. So you can create nbconfig with calling the mkdirect nbconfig. Or just copy paste the line of code here. This is a line you want to, so you make directory abconfig. Then you type in nano notebook JSON. In your command, then you can create this JSON file. So are we good to start the answering the questions for assignment 1? Okay. First of all, we want to import NumPy and Pandas. And then because we already have our CSV data file in our folder, then we just call the CSV and name the data site as data. So this is how the data site looks like. We have column age, work class, if they're self-employed, private, or employed. FNL weight, education, education number, marital status, if they're married or not married, their occupation, would basically shows what do they do, and relationship, their husband, wife, in a family or not in a family, their race, if they're white, black, Asian, sex, if they're male or female, capital gain and capital loss, hours per week, how many hours they work per week, native country where they come from, UK, United States, China, and salary. Like in salary column, it lists if they earn less or equals than 50K per year or greater than 50K per year. So the first question is how many men and women are represented in this data set? So we need to count the number of men and women. Then we need to look at the sex column. So we select the sex column and then filter based on if they're male or female, and then count the numbers. So I made a list because it will be easier for us to understand. So I firstly print male and then count the male, and then print female, count the number of females. Okay. So this is an answer for the first question. We have 21,000 male and 10,000 female in this data set. And the second question is, what's the average age of women? Then we want to use the function mean. Again, we select the sex equals female and select their age, and then calculate the average by calling the main function. And in our data set, the female is 36. The average age is 36. The third question, what's a percentile, or what's a percentage of German citizens? If we want to know if they're German citizens, we need to go to the column called native country features. And because we want to know what's inside native country column, then I use the function name called unique. If you call unique, we can see here is a list of countries in this data set, and we want to find the German. So when we wanted to calculate the percentage, we count the numbers of German citizens divided by the total number of the data. So we filter the column value equals Germany, and then we count the numbers of people in German and divided by the total number of people in this column. And we get around 4% of people from German in this data set. The 4 and 5 question are, what are the mean and standard deviation of age for those who earn more than 50K per year and those who earn less than 50K per year? So if you want to know if they're less than 50K or greater than 50K, you go to the salary feature. And you want to know the mean and standard deviation of their age. So basically you select the age because you want to count. You want to do the calculation based on the age. You select the age column and you filter by if they're less than 50K or greater than 50K. In this case, like I want to firstly take a look less or equals than 50K, then I filter by less or equals than 50K, then I use the function mean and the standard deviation to calculate. Like here it shows the average age for the people who earn less than or equals than 50K is 36, and the standard deviation is 14. And I do the same thing for greater than 50K. And then this is the average and standard deviation. The question number 6 is it true that people who earn more than 50K have at least a high school education? So we want to know if all the people that learn more than 50K, they're highly educated, their education is greater than high school. However, like how do we know? So we filter based on the greater than 50K, and then we call the education level, and then we type on unique. So if they are all highly educated, then we won't see grade 1 or grade 2 in this data set because we already filtered out. However, in this case, we still have 7th, 8th, 1 to 4th grade. So which means it's not true that people who earn more than 50K have at least a high school education. Question number 7, display age statistics for each race and each gender. So we want to know the age statistics. Use a group by and describe. Group by, we all know, is group by the category or group by the numbers. And describe is the function that describe the statistics of like the distribution of the values in the column. So in this case, we select the age, describe the age column, and we group by the sex because we want to know the age statistics for each gender and each race. So we group by sex and group by race. And this is the document that described the Pandas describe. So Pandas describe is descriptive statistics. It shows the descriptive statistics. Those are those that summarize the central tendency, dispersion, and shape of a data set's distribution. But we need to pay attention that if we use this function, it does not include the non-values. we can use the describe for both categorical data or numeric data. So analyze this describe function analyze both numeric and object series. Here is an example. This is the numeric series. It will provide the count, mean, standard deviation. If like how many are in 25 percentile, or like 20, what's the number of 25 percentile, 50 percentile, and 70 percentile. If your values are categorical data, then it will show the unique top frequency. And it also can describe the time stamp series. For instance, if you have the time series data, then it will count the frequency first and last. So this is a very, very useful tool of understanding the data. Question number 8. Among whom is the proportion of those who earn a lot? Earn a lot we can define as greater than 50K. If they're married or single man. So first of all, we need to define who is married, who is single man. And we want to filter only by male because we do not consider female. And then we take a look at the salary feature if they're greater than 50K or less than 50K. In the data set, we have marital status column. However, in this column, we can see that it's not very clear to show if they're married or they're single man. But in the question, it said like any consider as married those who have a marital status starting with married, such as married, savvy spouse, married spouse, absent. So how can we do? Like my solution is I copy this marital status and insert a new column called mar. And then I replace the values never married, savvy spouse with bachelor, married. Like I define based on the description in the questions, I define if they're married or bachelors. And then I use a function called pivot table. I firstly filter based on the sex. We only consider male, and then pivot table index as mar. Index is like as you can see from the results, like we want to set the first column as an index. So we want to know if they're married, then they can earn a lot or not. And then the column value is salary. The column here, the values in the column will show as column less or equals than 50K or greater than 50K. And then we use the egg function count. Then we count the numbers. So the values as age, we can select any columns. It cannot be, it does not need to be age. It can be race, because we just need to count the numbers. We just need a column. We all know that Excel has has pivot tables. This Pandas pivot table just to do the same thing. You just need to identify index column and how you're going to represent the values based on like what kind of function. You want to count the numbers or you want to just do an average. From here, we can see that for the bachelors, it's hard for them to earn greater than 50K. However, for the married men, lots of them can earn more than 50K, which means if you want to earn more money, then you need to get married first. Question number 9. What is the maximum number of hours a person works per week? So we want to know the max value of works per week feature. Then we call the max function. And then we get 99 hours, like is the most number that people work per week in this data set. How many people work such a number of hours? We want to know how many of them work 99 hours. So we filter based on 99 hours. So we filter based on the values equals to the max, and then we count the numbers. We have 85. And what is the percentage of those who earn a lot among them? Among those people who works 99 hours, we need to add another filter. So we add another filter greater than 50K, and then we count the numbers, and then we divide it by the total numbers of the people who work 99 hours per week, and we get the percentage, which is 29%. This value shows that if you work 99 hours, it doesn't mean that you can earn a lot. So it really, the salary doesn't depend on the number of hours you work. Question number 10, count the average time of work for those who earn a little and a lot for each country. So we want to know the list of countries, what's the average number of hours based on if they earn less than 50K or greater than 50K. Again, we use the pivot table. In this case, we want to set native country as index because we want to know the list of countries, their values. And then the column, again, we set salary because we want to know like what's the numbers greater than 50K, what's the average work hours they work in order to earn greater than 50K. The values is hours per week, and the egg function is mean. And then we get these results. In the question, they want to know the Japan value. So if we go to data set Japan here, in Japan, the average number of hours that people who work who earn less or equals than 50K is 41 hours. However, if they earn more than 50K, the average working hours is 48 hours per week. Yeah. So those questions just show how people do exploratory data analysis with pandas by giving a data set. However, I found like one function is very, very helpful for understanding the whole data set, which is called Pandas Profiling. From your notebook, if you type pip install Pandas Profiling, and then you import the Pandas Profiling and call Pandas Profiling profile report and call this data set. It will give you a summary of the data set. Like it will save you time for writing the line of code for each columns because this function just gives you an overview of every every column you have in the data set. This is how what the report shows: data set information, variable types, and they analyzed each feature. If they're categorical or numeric. And it shows the distribution max value, mean, and minimum value. And then the report will also give you correlations between those features. If there are any missing values. Yeah. So just from my end, I found this function is very helpful and might be good to share with you guys. Basically, that's it. And this is for like the whole thing for assignment number 1. And I would like to pass to Chen to show how we do this assignment in R.
Thank you, Joyce. I think you did a great job in introducing the wrap text idea in Python. I think it's great. It can improve your code readability and improve your work efficiency by making less mistake, because you can have a whole view of your code. And I extremely like the idea of Pandas profiling. That is awesome. Thank you so much.
Yeah. Okay. So I will just stop sharing and you log in.
Yes, please.
Okay.
Okay, I'll take it from here. I think Joyce did a great job in explaining everything, how you do the data analysis using Python. And now I would like to introduce how would you do data science with R with this one particular powerful and essential package called Deplier. A library is like a module in Python. So when you do Python, you call import a module, and in R, you just say library. And I put this command here, like if you never installed this package, you could do the command install packages called Deplier in your console here. But if you already did that, you just run this, you just run this command library Deplier. And R Studio is an IDE for R language. Since we started with Python Notebook, I thought it would be a great idea if we do the file, open file, and R Notebook. It's very similar to Jupyter Notebook in terms of you can put your code in chunks and run line by line, and you can generate the results immediately at the bottom. And in this Deplier package, it's essential for data transformation. And we'll be using the 6 main functions today. First one is select function. It allows you to pick variables by their names. And the second one is filter. Filter allows you to pick observations by their values. And the summarize function is useful when you want to apply aggregate functions to your data set. And mutate function allows you to create new variables with function of existing variables. And the arrange function allows you to reorder your data set. And all these 5 functions can be used in conjunction with the group by function. So it allows you to manipulate and analyze your data group by group instead of the whole data set. So the first step is we read a data set from the Excel spreadsheet. There are a lot of data structure in R, like data frame, data table, a table. And since we started from Python, I decided we use the same idea of data frame. So if you run this, the read CSV command, because the data source is stored in a CSV format, and then you just read it from this CSV and sort it in a variable called data1. And they had a similar head output, but in R, it prints the top 6 columns in your of your whole data set. If you take a summary of this, first I would like to mention some of the columns, they are integers, but some of them are called as factor. Well, a factor is a string a factor is a string that comes with character strings. They are a representation of several levels. So let's think it this way. If you have a column called days of the week, and then the levels will be Monday, Tuesday, Wednesday to Sundays, and this column will be a limited representation of this 7 levels, like Monday, Tuesday, Sunday, like that. And that is called a factor. The powerful part of the factor is when you do the summary of the data set, R allows you to R summarize the data set for you automatically, and we can have a better view of it. Like if it's a numerical column, it shows all the statistic values. If it's in a factor, for instance, our first question, it counts the female and male. These are the 2 levels for the sex column, and they count the number of repetitions for each levels. And if we go back, and if we go back to the main one, I would like to introduce an idea of string as factors. The factors are powerful, but it won't allow you to do some of the analysis, like take the mean of it, count. Basically, if you want to apply aggregation functions to the factors, that is impossible in R. So when you read the data, it's better to add a string as factor equals false, so that you don't read it as factors, you just read it as a common character string from it. And R has a command of view data, so that command gives you a better view of the whole data set, and it opens the whole data set in another tab. And if you go back to our main tab, you can also use the head function. You can also determine, let's say, the top 10 rows of the data set. You just add 10 at the end. And if we do the summary of the data, so first it was, if you don't specify string as factors, it's a factor. Now it's just a character string. And if we took a look at the summary of this data set, for instance, it won't count the times of repetition of that levels. It just tell you the length of it, the class and the mode, they are character strings, and that's it. And now we jump to the first question. How many men and women are represented in this data set? You could always read it from here, the female 10771, male, the number. But we can always use the library dplyr to perform the data analysis. So first, we want to see the male and female, then it's 2 groups. We use a group function. Let's say group. And in R, we don't use the equal sign. We use a less than and a minus sign together. It's basically just like you put a value to a variable and that's it. And we can use the group by function first. You see, when it jump, you can tab to fill it automatically, and it shows this function is in dplyr. And all this function, the first argument is the data set that it's referring to. That's the object. So we're working on the data object. And the second part is we want to group by a certain column, and here it's called the sex. So if we run it, and the whole data set is called by group. But if you don't specify it, R automatically suppresses from printing the result. But you can always view the data set by clicking here, or add a view group command in your terminal or in your console, and that's it. And if we go back to our script, that's it. Once you group it, now you want to count. Count is, you want to count the repetition. It's an aggregate function, so we're using the summarize. And we call it count, summarize. It doesn't matter if it's end with SE or RE, or it all refer to summarize function in dplyr. Again, you're working on the you're working on the group object because you already group it by sex from the data. And then you're working on the group and you're summarized by the count. In R, it's just the N with parentheses that count the repetition of that. And if you want to see the output, you can put a parenthesis outside your comment, and then that's it. And now I would like to introduce a very powerful concept in R. It's called pipe operations. So if you're working on a data frame, for instance, you're working on the data, you don't actually care about the results that's generated by group by. You just wanted to know after it's grouped by the sex, and you want to see the count of the levels of female and male in that data set. Then you should use pipe. A pipe is a piping idea. It starts with the object you want working on, and then there's a percent, larger than percent. These 3 characters perform a pipe operations. So it allows you to perform the pipe operation. So first you want to perform the group by function on the data set. But since you already defined the data here, because it means everything you're working on is performed on this data set. So you don't need to specify the first argument, the data set you're working on. You just say you group by the sex. So from the first command, you delete the first argument. You just need to start with the second argument. And after that, you want to perform another function on it. It's called summarize. It doesn't matter if it's SE or ZE, the player really is the same. Again, you don't need to specify which data object you're working on because it's already like pipe into this command. So you just start with count. And that's it. If you print the results, it shows the same. So if you're working on a large data set with a lot of functions you want to apply to this data set, it's highly recommended to use the pipe operations that could increase the readability of your code. It makes you don't need to generate all this intermediate data set that you don't actually care about at all. And the second, the average age of a woman.
Sorry,
so okay.
Chen, I have a question here.
Yeah.
I think you got a question in the chat. Maybe you can answer that question first.
Oh, okay. But I really cannot. How do I? Oh, chat. What's the main difference between right? That's a good question. If you go to File, New File, and you open it R Markdown, it has a lot of output format, I'll say. I think it's a more interactive page for you to write code on it. So could I just like read more information and get back to this question, because that one really got me. I don't have the answer at the top of my head at this moment. I think that's a really good question. Yeah, I would agree. It looks very similar. And the R notebook is very similar to Jupyter notebook because you can run your code line by line in a chunk, things like that. So I go with R notebooks most of the time. Thank you, Lynn, for this question. That's a really good one. I should have more information before this presentation. Okay, now let's move on with the second question. Okay, let's open the file and read it. Thank you for the explanation from the committee. Thank you very much, and from Daniel.
I think basically you're right, Chen. Like for the notebook, it's more interactive. For the markdown, basically it just runs one line of code at each time. You cannot actually put all the code in the console to run everything. But in the notebook, it's kind of like refreshing everything once at a time so that you can see all the output at a time. But for markdown, just like you said here, it's like you click, run like that button. You can only run that specific section. I think that's the difference.
Thank you for backing me up. Thank you very much.
So I actually have a small question here. So the pipe here, like the difference between the pipe in R and Python is like in the Python we can actually write a long line of lot of same like commands at the same time. Like it's like row by, then count, then do the main. But in the R we cannot do that, right? So that's why we use the pipe here.
I wouldn't say R cannot do that, because in part of my function, you can use one function parenthesis, and then you put another function in that parenthesis that we will encounter later, such as you can sort and unique on that data frame. Like R can definitely do that. And the beauty of Python is like you can have one object, dot function, dot function, dot function, if they work on the same object. I think that's a very similar idea, but R, they use a different way of doing that. It is the same like the same
So
concept.
for example, suppose I just try to do a group by, then do the count, like in the chat, I just type the code, which is the Python code. But in R, you cannot write in this way, right? You have to break into two different functions and put into a pipe. Is that what you mean? Exactly,
because in Python, like in R, count is a like you perform on the observation of that column, so it belongs to the summarize. Gotcha. And the group by is like you want to group this data step by step, and then you can perform the summarize on each group in your data set. So it's not like you group by and then you do the count. It's like you do it in a parallel way.
Okay, gotcha. Thank you so much.
You're welcome. Okay, so we jump to the second question, the average age of women. We first start with the data set, and then we do the pipe. You can read it as thin or piping, whatever you like. And my personal behavior is like, I start with select, like it's like with the age and the sex. So like when you perform your data analysis, you can only read those two columns that you care about. In a real life project, you may have a lot of columns, a lot of numbers. Some of them are irrelevant to your analysis. That could be very distractive at that time. So you start with select. And then we want to see the women. So we do the filter, and then we filter the sex to female. And after that, we want to count the average age. That is an aggregate function in the summarize. So we do another pipe function. We do the summarize. It doesn't matter SE or CE. You just count the average. So we do the average equals mean of your age. This is the output of that. And in the summarize, the age is like you will create a new result, and the results you put the name to average, and then you do the mean, which calculate the average of the age after you filter all your data sets. I would like to say like this data set provided with the machine learning courses has already been cleaned up. There's no missing values. Everything is working just fine. But I would highly recommend you put an any remove equals true when you do the aggregate function. You put it in the summarize almost like a reflection, because like when you do the real life project, there will always be missing values in that. And it returns the same result because there's no missing value in this data set. Now we move to the third, the percentage of German citizens. I provide another solution in this assignment notebook I handed out yesterday. Like you can count like the German citizens, and then you count the total citizens. you divide German citizens by the total citizen, you get the percentage. But I would like to share my personal trick of calculating percentage or proportion, anything like that, by using the mean and the logical output. So you take the mean of your data, and in Python, when you want to call a column in a data set, you put in R, you put a $sign. So it will show all the columns available in your data set. And now you just want to choose the the column that you're referring to, the native country. You can hit tab, so it automatically fills in the rest, equals Germany. And again, since we're in the mean function, remove NA like a reflection, and it'll automatically calculate the percentage. Because in this equals German, it returns a true false value. And when you do the mean of it, it just automatically converts it to 1 and 0. You count, it can summarize the true observations in this command and divided by your total count. That is exactly how percentage is defined. You can use just one line of code to get the percentage instead of calculating the German counts, total counts, and do the division 3 steps. That's very powerful. And now we move to the 4th and 5th question, the mean and standard deviation of age for those who earn a lot and who earn less than 50 K per year. Again, we start with the pipe operation. We select the columns we care about. That will be the age and salary. Then we do another pipe because we want to group the data set because they want to show the results like who earns a lot and who earns less. That will be the group by salary. And then you add another pipe because you want to calculate the mean and standard deviation. They are aggregate function and a summarize function. So first you calculate the mean equals mean of age. So you put age in the mean parenthesis. Again, always remove NA. And then you can always calculate standard deviation. In R, it's called SD. We put the age, again, remove NA. And that's it. If you print the result, it shows the mean and standard deviation based on your data set grouped by the salary. And if we jump to the number 6, is it true that people who earn a lot have at least a high school education? And that goes back to the answer I mentioned. Like, can R use a lot of functions at a time? The answer is definitely yes. For instance, we can use the unique function to see like what are the levels in the educational level column. So we do the data and we put the $sign, tab with education that shows all the unique values in it. And we can also add a sort function behind it. It's not like one function dot another function, but usually you put a function in the parentheses of another function. So you sort the result, arrange the result, arrange the outputs. You can definitely do that. And we can read from it, they all have other levels here. So this is not true to this question. Number 7, display age statistics for each race and each gender. Use the group by and describe. And definitely R have this function and the describe function. And if we go back to the first when we summarize this data, the table, you see all the statistic results that automatically generated by R, the mean, the quantile, things like that. But we can do the summarize and get everything that generated from the Python statistic result. We start with data, and we select the columns we care about, the age, race, sex, and that's it. We put another pipe because we want to do the group by function. We go to the group by, and it says for each race and each gender, so we group by two variables here. The first is sex and the second is race. And then we can do all the functions. For instance, in Python, they start with count, and we can start with count. Previously, I introduced the idea of using and parentheses to count here. And now I would like to introduce another idea. Is like when there is a missing value in your data set and you want to count those non-missing values in your data set, so you can use the sum of non-NA values. And there is, and in R, the command is like is NA, and you're working on the age. So it returns like true or false. And you wanted to calculate the non-missing values, so you add a exclamation sign like in the front of it. So it calculates all the non-missing values, and then you take the sum, so it converts the true, false to 1 and 0, and it calculates all the ones in the age. And the second one is mean. It's similar to the mean. Age, NA, remove, true. I'll copy paste this sentence because we will use a lot. And STD will be STD. Then we're going to the mean. It's very simple. You just take the mean of it. Then we move to the quantile. In R, if you do the quantile of the data, let's say the age, it returns a vector directly, like from 0, 25%, 50%, 75% to 100%. And if you want to read the, let's see here, if you want to read the 25% of it, you start it. And then you just read the quantile of age. And then you put second here, because the 25 is in the second position, and R starts with 1 instead of 0 in Python. So if you want to read the 0%, you start with 1. 25%, you put 2. And similarly, if it's 50%, put 3. 75%. Put 4. And the last one in the Python statistics output is max, and R can definitely do that. Paste it. And we run the result. It shows it grouped by the sex and the race, and you have all the statistic values for this group. And it doesn't have to be the one I showed. You can have whatever you want, as long as the summarize function provided. And now we jump to the number 8. Among who is the proportion of those who earn a lot? Okay, again, we start with the data pipe, and we select the columns we care about. That will be the salary. And then there will be the marital status. And that's it. And then we group by the salary, because, sorry, not the salary. We group by the marital status. And then we add another pipe function. We go back to the summarize. Again, we will calculate the proportion of it. We can use the mean and the logical operation to get the percentage easily. So that would be proportion. That's the column name that you want the output to have equals to the mean of. Again, those who are married, they all have a string that starts with the married. So R has a similar command, starts with, so you put, there are two starts with here, one in the multiplier, but this could be the tricky one. It doesn't allow you to filter your observations in a column. This starts underscore with operate on your columns. Like if you have 5 columns that says, let's say you have a column called age, you have a column called and then it says starts with A, then it would choose the column age and end, but you don't perform it on your observations within each column. But in the base R, it provides the start with that it could filter all your observations that start with a certain pattern. So now in the space R, you need to the first argument it takes is the object. That will be your data, marital status. And the second column is the pattern you refer to. Now you said it starts with married. And since we're using the mean function, again, remove NA all the time. No, that's not what I mean. I must got the result. Group by salary, sorry. Yeah, and when I first made this question, I didn't read it clearly. It says a single man, so I need to add another filter function here. Male. You add another pipe operation, and since you want to have this filter on it, but when you select, you didn't select the sex, it will return an error. So you need to put sex here in your select columns, then you can do the filter. So among who, like for those who earns a lot, that is the percentage of your, well, I don't think I get it right. I'll just remove this comment. No. How about I just copy paste this? Okay, I did this earlier when I have a clear mind. You first select all these columns you care about, you filter by the sex, female, and then group by salary, and you do the proportion, which you do the mean function with it. And for those you want to count how many persons are married, you can do the married equals to the sum that starts with this married. And for those who are not married, you start with the marital status in those. And there's another powerful pipe operations called pipe in. It's like percent in percent. It says like for all the marital status that's in a vector of divorced, never married, separated, or widowed, it returns true. And in R, when you want to create a vector, you start with the lowercase c, and the parenthesis of all these things, it's a vector, and that's it. Oh, I add a mutate function in the end because I want to see if did I calculate correctly by using the mean. If we don't use the mean, we can definitely calculate the proportion by, for those who are married, divided by the total number of married and non-married, we have the similar results. So it proved like by using mean, you can get the proportion of your data very quick. And now we jump to the number 9, the maximum number of hours a person work per week. How many people work such a number of hours and the percentage of those who earn a lot. Again, in the notebook I hand out yesterday, I have 2 methods for these questions. You can get the max and then you can filter. You take the percentage step by step, but we can perform with one command using pipe operations, and we can filter the results in the end. First, we start with the data. Select the columns. The first will be hours per week and the salary. And then you group by the hours per week. Then you do the summarize function on it. First, it's first question, how many people work such a number of hours? So you do the count. You can use n parenthesis function to calculate the count. We can also use the sum, none, and the values. And the second one, we want to count the, we would like to calculate the percentage of it. So the percentage, how do you spell percentage? Okay. Again, we can use mean. And when we do the mean, we can calculate the salary equals to larger than 50K. And that's it. And since we want to know the maximum number of it, we can arrange the output of the results. So we do the arrange function. If you don't specify the order, that by default it's in the ascending order. But now we want to see the maximum. So we want the results to be printed in the descending order. You just specify descending. And the hours per week, like descend in like this column, print out in a descending order, and that's it. So the maximum number of hours a person work per week is 99 hours. 85% works as such number of hours, and this is a percentage of those who earned a lot. And now we jump to the last question, the average time of work for those who earn a little and a lot for each country. And again, what would this be for Japan? So we start with the data. Select the columns first. Hours per week. Salary. And then group by. To country and salary. Did I select native country? No, I'm sorry. You definitely need to select the columns you want to work with. And then you just do the summarize function. On your average time of work, AVG, equals the mean hours per week. And a remove equals true. And that's it. It should give you the results you want for this country it first grouped by the country, then grouped by the salary. And for each country who earns a lot, this is the average time of work. And this is for another country who earns a lot, who earn a little, the average time of work. And we want to know specifically the results for Japan. We could add another filter function. It says native country. And ta-da, it just shows for Japan, who earns a lot, the percentage, the average time of work for those who earn a lot and earn less. And that's it. The dplyr is one of the most basic package in R if you want to do data manipulation. And the 6 function I just introduced can cover 90% of the work you want to do. You want to do data wrangling or data transformation with R. And that's it. It's very simple. I hope you like R. The science, they have the PDF version online. Not sure if it's copyright issue with that, but it's definitely for free. And I use another one, R Cookbook. That's it. These are the 2 books I refer to. And for the Shiny, like I didn't start it with the data visualization part of R, but since like my project was the data visualization, so I just learned it by looking the YouTube videos, data camp, but you have to pay for data camp. That's a pain here. And there are a lot of questions from the Stack Overflow. It solves 80% of my questions when I'm using Shiny for my project. I would highly recommend just Google the questions, like Google the error message and find the results from Stack Overflow.
I think like, you know, I think I totally agree with you, like R is a powerful tool, but I mean, it works better than Python in some kind of specific task, especially for the data analysis part. But if you try to do some kind of natural language processing, NLP over there, then I don't actually really suggest you guys to use R, because it's more like a number or math-based like language, not like, you know, like a text-based language over there. So if you want to actually do a little bit more interactive like language or like a text, some kind of like models, you're probably gonna prefer like Python than R. But other than that, like R pretty much, you know, works across basically all the models I know in Python can be loaded in R, because they have pretty much the same kind of version of the libraries over there. So yeah, I think they're kind of like equally, you know, kind of powerful from that perspective.
I think Daniel makes a good point here. I like R and I like Python. It doesn't matter which language you choose. There are a lot of beauties and amazing things that could happen within the language you choose. You just keep digging and you will find like this is a very powerful language when you're programming.
Yeah. I think there's a one question like, is R much faster than Python? What do you think, Chen?
I really don't know the answer. I think you make a good point. It depends.
Yeah. Yeah, I think the language doesn't differ too much, like with respect to speed. It just like, it depends like how large a data set, like what kind of parameters you put for the model and what kind of memories you have for the computer. For a language itself, it doesn't really have, you know, kind of an advantage or disadvantage which one actually runs faster than the other one. So because today's data set is not that huge. It's actually not a huge data set. Like today's data set is kind of like a medium size or even small size. So when Chen actually type one line, you can run that line, you know, really quickly. But if it's a huge data set, data set, you're probably gonna, wait for like 10 seconds to see the result over there.
Yeah, and it also depends on the package you choose. Like decades ago when they built R, it's just in the base version, but then different people build different packages with different functionalities. So it really depends on which package you're using and what's your goal. Sometimes it can take a little longer, but it takes less memory storage for you to print out the result. Sometimes it takes longer, but it only occupies a little of your RAM. It really depends.
Does R, because I learned R many years ago, like, but I kind of forgot about this part. Does R has some kind of like, cloud computing or parallel computing tools like Spark or Python?
Yeah, they do.
Okay. So next week, I think we got 2 more assignments. Next week gonna be from Laura, from Zehao, from Wang Ruibing. So, and one more assignment next week, assignment 3 over there. So I'm just like, I'm kind of concerned, like, do you guys want to keep going for the assignment, like keep doing the assignment, or